Steady state exercise. Steady state exercise is when the body is working at a steady state. This means that the lactic acid removal is occurring at the same pace as the lactic acid being produced. An example for a steady state exercise will be jogging outdoors or on a treadmill, pedaling an exercise without changing resistance settings or pedaling speeds, or aerobic dancing that uses most of the same rhythm throughout the class. Cardiovascular system. The heart rate will start to increase as you do a steady state exercise. This is because your body will need more blood pumping around your body for your muscles to stretch easier and more oxygen going around with the blood. Stroke volume. When you start an exercise, there is an increase in venous return. There will be a greater amount of blood supply to the heart, which this allows the cardiac muscles to stretch with no tear or injury. This is also known as the Starling's law. Thermoregulation. Our body's normal temperature is 37 degrees Celsius, and if it lowers or increases by even 1 degree Celsius, it will affect the whole body. Heat gets lost by the sweating. Sweating starts to evaporate and cools the skin down. As we start to exercise, roughly 15 to 25% of cardiac output is gone to the skin. As we start to exercise, roughly 15 to 25% of the cardiac output is gone to the skin. The body is too hot. Vasodilation and vasoconstriction takes action in the cardiovascular system. This is because when you're too hot, vasodilation will go towards the surface, which is the skin, to keep you cool, and the vasoconstriction will go towards the center of the surface. Vasoconstriction will go towards the center of the surface to keep all the major organs warm, because all the vasodilation, all the vessels will go to the surface at that point, whereas it will leave all the organs with no blood. The respiratory system. Our bodies need more oxygen as we start to do more exercise. We therefore start to breathe out more carbon dioxide. Oxygen dissociation curve. The temperature has an effect on the curve, but this is only a slight effect. This will shift to the right as the temperature will increase, and it will shift to the left as the temperature will decrease, but it's only a slight change. The breathing rate will also change. The breathing rate will increase as we do more exercise. This is because our body will need more oxygen. When it starts to increase, it will then stay the same as doing a steady state exercise. Within the respiratory system, the tidal volume will also change. Just like stroke volume, the tidal volume increases because your body needs more oxygen, so the depth of each breath increases to gain more oxygen in the body and in the muscles. The neuromuscular system. Pliability. When the muscles warm up, the muscle becomes more pliable. This enables the muscle to become more stretchy without tearing them. When the muscles warm up, the rate of the nervous impulses increase. The speed of transmission will start to increase too. The energy system. This system is responsible for producing most of the energy supplied to the body. The aerobic glycolysis. The glucose is broken down as there is still oxygen existing. It's now broken down into pyruvate. This is because the oxygen is still present. This will now enter the series of reactions. The Krebs cycle. The pyruvate bonds with the coenzyme to form an acetyl-CoA to produce ATP, hydrogen, and carbon dioxide. The mitochondria. This all takes place inside the mitochondria. The folds on its surface gives more surface area for the energy production to take place. The folds are called cristae.